All right, I think this is a good time to get started. Welcome in, everyone. If this is your first time attending a live training workshop with Cyber, then welcome. We're glad to have you here. If you're a repeat guest, welcome back. Glad to see some familiar names and faces in the audience today. As I mentioned before, we've got a couple of polls going on, so please go ahead and respond to those really quickly if you haven't yet, just to give us an idea. Looking at results here, most people are using AWS for personal stuff. We've got a few people who are also running it into production, and then some of them who are they've heard the term AWS, right? It's a popular term, but maybe they haven't used it yet. And so I think this is a pretty good spread today. And then in terms of Terraform, so we have a lot of people who are familiar with it, but they haven't actually used it yet. And so I think this is going to be a very good introduction for this. Now, if you've already used it before, this might be a little bit more introductory level than you need, but you never know. I mean, it's great to look at somebody else that has expertise in the tool that you're using and see if they can teach you something a little bit different than that you're not already familiar with. So either way, everybody here is welcome, and we hope you get a lot of value from today's presentation. The way that these presentations work is very straightforward. So if you've never attended before, a couple things I want to mention as we dive in here. The first is the most common question we get, which is, yes, absolutely, this workshop will be recorded and we will be sending it after the fact. So it takes a few hours to process the video itself. So I'll send you an email probably in about 24 hours. You'll get that in your inbox. If you didn't receive it in a couple of days, then feel free to shoot me a DM on LinkedIn or Discord, and I can send you the link directly to it, but you should get that email. And then we will also be publishing it on YouTube in probably about a week from today. So this will definitely be recorded, but that way, as you go back and try to implement what we're doing today, you can definitely do that. But hopefully you'll be able to engage and interact as we're doing this, and not just watching, but actually taking what we're doing in this presentation and applying it in your own accounts. So we're going to walk through today's session and agenda really quickly, and we're going to start with introductions so that I can explain who I am and Tyler can introduce himself as well. And then after that, we'll go through just a handful of slides before we switch over to screen sharing and actually showing you the code. And we'll be deploying a static S3 website today. So that's a really good use case of doing something that really doesn't cost any money at all, but that will be deploying real resources in AWS. And you can also use that for personal blog or some other type of static website project. So it's a nice, easy, straightforward project to get started with, especially for Terraform. So we'll talk about how to set up Terraform. Then we'll talk about how to authenticate using the AWS command line interface, or CLI. So if you've not done that before, we'll give a quick rundown of that, because we need to be able to do that in order to launch resources on AWS. And then we'll actually deploy those S3 resources that I was just talking about, before we then talk about how do you manage those resources you just deployed? How do you update them? Maybe you have a misconfiguration, or maybe you want to add something down the road. How can you update that through infrastructure as code? And then finally, we'll also talk about how to destroy our resources so that when we're done with them, they're not just hanging around collecting dust in our AWS environments. Did you want to add anything to the session that I've left out, Tyler, or is that a pretty good summary so far?
No, I think that's a great summary, Christoph.
Perfect. So in that case, we'll dive into introductions. I did forget to mention one thing that's very important with these workshop sessions. I want to make sure you're asking questions. This is meant to be interactive. This is not just us presenting to you, right? We want you to ask questions to get feedback. Is this making sense? Are we skipping steps? Did we miss something important that's preventing you from understanding what we're talking about? If that's the case, or if you have any questions at all related to the subject, you can click on the Q&A tab. It looks like a question mark in the software that you're using right now. And you can ask your question, and we may answer it right away, or we may hold questions until the very end. But either way, as soon as a question pops to mind, go ahead and put it in, and we will be able to get to your question. But on that note, let's talk a little bit more about who we are, so that you know that we're not just making things up. We actually have some experience with AWS. My name is Christoph Limpelere. If we haven't met yet, I'm the founder and trainer at cybr.com, where we do AWS security training. So we help you learn how to build on AWS, but also how to build securely on AWS with practical resources. And I have over 8 years of actual AWS experience. Prior to that, I was also a web developer. So I come from a software development and application security background. And then within the last 8 to 9 years, I've been really learning about how to build on AWS and how to build securely on AWS. Otherwise, I currently reside in Colorado and I love hiking and skiing, as you can probably tell from the picture on this slide. But on that note, I'm going to hand it over to Tyler. Did you want to go ahead and screen share from here, or did you want me to keep screen sharing and then you take over?
Yeah, I can take over. That's fine.
Okay, perfect. Let me go ahead and stop then. I think it'll make it easier going forward.
Yeah. All right, let me make sure I share the right window. All right, how's that? Can everyone see that okay?
Yes, yep, it pulls up fine.
Cool. So my name's Tyler Petty. I currently work as a security engineer. I've got a decade worth of experience in the industry, primarily in cybersecurity, but I started my career as a sysadmin working in Windows, moved on to security engineering, did some time as a manager, and then decided it wasn't for me. So moved back into security engineering couple of years ago. So I also live in Colorado and I do enjoy hiking as well. Okay, so if we talk about what Terraform is, so Terraform is an infrastructure as code language that allows us to build, change, or manage our environments. And we do that through the use of something called a Terraform provider. And we'll look at what that is later, but it's essentially a piece of code that abstracts all of the API calls needed with these integrations. So it integrates with all the major cloud environments, AWS, Azure, GCP, on-prem, maybe VMware or Proxmox, and then other solutions as well, like Okta or Salesforce. And then it's written in HCL, which is HashiCorp configuration language, which is declarative in nature, which means that all we have to do is say, hey, Terraform, go do this. And it's going to go ahead and take care of doing it. So it could be, hey, go build a virtual machine, go assign this IP. So it's declarative. We just tell it what to do. Terraform figures out how to do it. And then there's numerous benefits, but some of them being versioning. The fact that we create all this infrastructure, all these resources with code means that we can version it. So maybe version 1, your virtual machine is unencrypted. And then we go and update the code. Version 2, now it's encrypted. So example of versioning there, scalability. Again, the fact that it's code, we can share this code with other people, with other teams. We can use the code and rerun it to create multiple resources or deploy in multiple environments. And then Terraform has something called a state. So anything that Terraform either creates or manages, it maintains, all of the details about those resources. So if it's a virtual machine, here's my virtual machine, here's the operating system that's running, here's the firewall rules, etc. And then security and compliance. We can, again, codify all of those requirements into our infrastructure. So maybe we need to ensure that permission policies are least privilege. We can codify that. We want to ensure that these resources are encrypted. We can also codify that. So just some pretty awesome, benefits of Terraform. And it works on all the major operating systems. So Mac, Linux, Windows. If you have a package manager, that would be the preferred way of installing it, but you can go to HashiCorp's website, download and install the binary that way as well. Some of the popular ones, Mac has Brew, Linux APT, or there's Pacman, or other package managers as well. Windows, Winget, Chocolatey. Most of those should all have Terraform.
And Tyler, if I can interject just for a second here, because we actually did this workshop in person in the Denver area a couple of weeks back, or maybe about a month ago. And at this stage, I saw some people having issues, like on Mac OS, for example, if they try to install it, if they have an older version of VS Code, it was giving them all kinds of errors and so on. If that's your current situation, I would say don't try to troubleshoot it right now, because otherwise you'll miss some important stuff in this presentation. That's why we're recording this, right? So if you're able to install it right away, great, go ahead and do that. Fantastic that we can follow along. But if you're having issues, please don't try to troubleshoot right now. Let's go ahead and stay focused on the presentation, and then you can always go back or ask us questions at the end.
A great point. And then once you have Terraform installed, you can just do a Terraform -- help, and that will give you the help menu, all the commands that you can run and things like that. Just a way to verify that Terraform installed correctly. And Christoph, do you want to talk about this?
Yes. So we do have a free lab that you can launch to be able to follow along with this presentation. That lab was actually created specifically for this workshop. And so if you don't have an AWS account, or if it's not properly set up or anything, you can go ahead and log into your free Cyber account if you have one. And you can go to that link at the bottom there. It's just cyber.com/Terraform. And it will take you straight to that hands-on lab. And then you can just click on Start Lab. And within a minute or so, it'll give you credentials. And then we'll use those credentials throughout the rest of the presentation. If you have an AWS account, I highly recommend that you do it in your own account, to be honest with you, because that way you can see after the fact, like once we're done with this presentation, you can look at what we created and kind of digest what happened. Whereas with this hands-on lab, it expires within 60 minutes. And then after that, you lose everything. So it's all ephemeral and doesn't stick around. So if you have your own AWS account and it's set up and it works well, use that. But if you don't and you just want to follow along, then go ahead and log into your free Cyber account and then get started with this lab here.
Right. So we'll move along here, just a few more slides. So Terraform is, in this case, we're building on AWS. So we need credentials to AWS. So Terraform is going to use those AWS credentials to authenticate and build our website. So we would want to run AWS configure here, and then you'll put in your access keys and region. I believe, Christoph, for your lab, it needs to be US East 1. Is that correct?
That is correct. Yes. And if you want to take a screenshot of this, also below the lab, you'll have the same explanations that you see here. So no rush if you don't get to it in time.
Okay, so once that's all set up, the next command here, if you've ever used like who am I on a system before, it tells you who you are. AWS has a similar command, AWS STS, get caller identity. That's just going to tell you who you are and validate that your credentials and your profile is set up correctly. So this will need to be in place before we can build on Terraform. All right, so we'll move on to the demo here. Pull up my notes.
And while you're doing that, I'm going to paste in a message here. If you're able to read what's on the screen, if you can go to emojis and then give me a thumbs up, that way we know we're good to go. If it's too small, if you need us to zoom in, go ahead and give me an angry face emoji, and that way I can know what's going on. All right, I see a lot of thumbs up, looking good. If you can't see it, let me know, but otherwise I think we're good to go.
All right, perfect. So the first thing you'll want to do is just have a clean directory. So I'm in one right here, but if we needed to make a new one, we can run this make directory command. And then name it whatever you want. We can do Terraform Lab just like that. And ls to view, and we can see that we have the directory here. And then change into that directory. All right, so the important thing here is we're starting with a clean directory. There's no other files in there. The first file that we're going to make is called main.tf. So this is our first Terraform file. Numerous ways we can do this. We can do touch main.tf. I think if you're on Windows, it's maybe file. And then if you have VS Code, you can just type in code main.tf. So have your directory, have your main.tf file. And then the first thing we need to do is define a provider. So let me copy this link. So I mentioned before AWS or Terraform has this concept of providers, and the provider is just a piece of code that translates all of the Terraform code into the proper API calls that talk to AWS and then perform the actions. So we can go to the Terraform registry here, and then I have it open on provider. Now, the key thing is to see this little tag, this yellow tag here. That's the official provider for AWS, because anyone can create a provider, upload it here. That provider may or may not be configured correctly. It may or may not have malicious code. So you always want to be cognizant of what you're downloading when it comes to code. And then there's this button here, use provider. It tells us how to set it up. So we can just go ahead and copy all of this. I'm going to move it back to the code editor. And we'll paste that in. So configuration options, right? What do we put here? Again, we can look at the documentation, and we're going to need a region for sure. So we can type in region and then US East 1, which again, you want to use this region if you're doing Christoph's lab on cyber. And then if you are following along with that lab, that's all you need to do. I have a profile set up for AWS. So unless you've set up a profile or know what that is, don't worry about this command here. All right, and then the next thing we're going to run is a Terraform command called Terraform init. And so what this will do is this is going to initialize our directory here. It's going to look at what providers we have. In this case, we have the AWS provider, and it's going to download the version that we've specified up here, 5.60. Okay, so that's done. When that is done, we can do this command here, which will allow us to look at the hidden files and directories. And we can see that there's a new file called .terraform. So if we can do tree.terraform, or you can do ls-r.terraform. And we can see the version that it downloaded of the provider. Just a way of verifying. So the next thing we're going to do is look at creating a bucket. So I'm going to go over here, paste in the link. We can also search over here too. As you work with Terraform more often, you'll start to know what the resources are called, and it'll be easier to search for things. But so the bucket is what we're going to create here. It gives us an example right here, and then some of the arguments that we can set and which ones are optional or required. Buckets don't have anything that is required. They're all optional. So, we can copy this code over here, and we can come back to our file. And so, this is a requirement. This right here, AWS S3 bucket, that's the name of the resource. This piece right here can be named whatever you want. I would recommend, naming it something that makes sense. And just so that Terraform can track, like if we had multiple of these resources, it would know which one's which. So even though this was an optional argument, we are going to put the bucket here because we're building a website, and that website has to have a unique domain name. So in my case, I'm going to do, Tyler's websites, and then typically I would just put a bunch of numbers because it has to be unique. Like no other S3 bucket can have the same name in the world. So once you've got that code, we can save it. And then how are we doing? Any questions on that?
One question about whether this is being recorded, just to reiterate, yes, we are recording this, so you can always retrace your steps after the fact. The only other thing I would add here is, of course, right, we're creating the bucket name, and the bucket name has to be unique, and that will turn into a domain name. But if you have a custom domain name, like say cyber.com, that you want to point to an S3 bucket like this, then you would do that after the fact. So technically you don't change the bucket name, but you can point a real domain to it. And we're not going to be showing that in this presentation here, but just wanted to mention that in case anybody was wondering about it.
All right, so once we have that, we're going to run this other Terraform command called validate. And validate is going to look at our code and verify that the syntax is all correct. So we run that, we should get a success here. There we go, so it's valid. So what that's really doing is, it's looking at the code. If we had a different argument in here, one that, doesn't exist on the documentation here, we could just do like, fake argument equals this. And we can already see there's a red squiggly line to indicate that, hey, not expected here. But if I run that Terraform validate again, it's going to point out that line and tell me that it's unsupported. So that's all it's doing. So I'm going to go ahead and erase that. And then we are going to look at Terraform formatting. So I think, let's see, I'm going to make a new argument here. Just name it like that. And then I'm going to just make the spacing all wonky. You would have to save this file for it to work, but you could type in Terraform FMT format. And when you run that, it's going to readjust the formatting here. Now, because I have the VS Code extension for Terraform, it's going to go ahead every time I save my file, it's basically running a Terraform format. So when I save my file with Command S here, it's going to do the exact same thing that this Terraform format command is doing. So Command S, and you can see it makes it all pretty again. So that's a handy command as well. And then next, we're going to run a Terraform plan. Let me get rid of these tags here. So a Terraform plan is essentially a dry run. It's going to say, hey, I'm looking at all your code, and this is what I would do with it. So we'll run that Terraform plan, and it's going to output everything it's creating. In this case, it's making a bucket, and it's going to either tell you the property that you've defined in the code, or known after apply means once we deploy this resource, these attributes will fill in. So that all looks good. Plan is one to add, nothing to change, nothing to destroy. Looks good, we're making a bucket. So we can go ahead and run Terraform apply. And it's going to do a similar thing here. Except, similar output as before, except this time it's going to have us approve the action. So we'll type in yes, and then this creates the bucket. Okay, it's created. Now we can use the AWS CLI just to validate that the bucket was created. So you can type in AWS S3 LS. And then again, because I have a profile, I'm going to specify my profile as dev there. But we can run this command and we'll get back the name of the bucket. Right. And then also we can look at the Terraform state. So it's mentioned before, any resources that Terraform creates or manages shows up in Terraform state. And before we run that here, if we do an ls, we can actually see the state file here. And this Terraform state list command here is essentially reading this state file, and it's going to output something in a pretty format and tell us, hey, these are all the resources I know about, which is the bucket here. And then we can do a Terraform state show, and we can look at this bucket. And this is going to show us all the properties of that bucket. So all the things that, when we ran the plan earlier, a lot of this wasn't filled out with the exception of the bucket name. Now we can see the ARN of the bucket. We can see the domain name, all sorts of attributes about it, what region it's in, etc. All right. How are we doing so far?
Good. I'm not seeing any questions coming at the moment. If you have questions, if you're lost or confused, now is a great time to ask that. I was just going to say that last command you ran there is a massive time saver, because if you try to do that via the AWS CLI, you're probably looking at least 3 separate commands, maybe even 4, to get all that information. So that's insanely helpful, actually. We did have a question about the profile information. So just to go over that a little bit more, if you're typing in AWS configure and then you press enter, you paste in your access key ID, secret access key, etc., then you're not using a profile. or you're not using a different profile name, you're using the default profile. In that case, you don't have to specify the profile name. I'm pretty sure you could type in profile default if you wanted to, and that would work, but you don't need to do that because the CLI already assumes that's what you want. But if you configure like Tyler is doing right now with AWS configure dash dash profile and then a profile name, then in that case, you would need to specify that profile name. So in his code, he's using profile dev, which is why when he issued that CLI command, he issued AWS S3 LS profile dev. So that's going to go into your configurations and grab the correct access key for that call.
All right. So we've created our bucket. We know it wants to be a website. If we go back and do that Terraform states command again, we can get the domain name. I'm just going to copy the bucket domain name. You could also do the bucket regional domain name. I copy that and try to go to it in my browser. We're going to see this access denied, right? So we're trying to build a website, but we're getting access denied, right? So this isn't going to work. So the next thing we need to do is actually enable public access. So we're going to create another resource here. And get the link. And we're going to configure the public access. So in this example, we have to have a bucket, which we already do, and then we'll configure this resource here. Public access block. All right, and so it needs the bucket value. So in this case, we need the bucket ID, which again, this is kind of helpful of seeing the state, is we can get the bucket ID here, which is just going to be the name of our bucket. So we could just paste it in like that, and that's all fine. But if we later, change the bucket name up here, this is going to be incorrect down here. So what we can do is we can actually reference the bucket resource, and it's going to look like this. So we'll just type in, the resource name and then the name that we gave that resource. And then we need the ID attribute, which was down here, just the bucket name here. And now we just need to go ahead and set the, enable the public access. So we'll do a block public access. So by default, now when you create an S3 bucket, by default, this would be set to true. So we're going to set it to false. Public policy, there's an ignore, and there's a restrict. And all of this is coming from that documentation. We can see that all right here. So true, of course, makes the bucket private. We want to make it public. And then since we're accessing our bucket from the web browser doesn't have any kind of AWS credentials. We're essentially an anonymous user trying to access this resource. So that means that we have to create a bucket policy, which will allow anyone in the world access to the bucket so that they can see the website. And so let's go ahead and do that. Buckets policy. And then we need to refer to the bucket. That's going to be the bucket ID. So same thing. And then the policy. Now there's a couple different ways we can set a policy. We could have a separate JSON file that we refer to. We can do this as well. We can do a JSON encode. And then you can see I've already got a hint of what to do next here. But essentially, this is just it's just similar to an IAM policy, right? We're saying here, allow all principals, so anyone in the world, the ability to get object, on this resource. Now, that needs to be changed. And it actually is this. So the resource is going to be, again, our resource of the buckets, and then this time the ARN, and then we're going to add this slash star, which will say, hey, anyone in the world can get all of the bucket objects. So anything within that bucket. All right. So if we're good there, we'll run our same Terraform commands again. So we can do validate, make sure that our syntax is correct. We can do a format to make sure that everything lines up appropriately. We'll run that Terraform plan. This will tell us what it's going to create. In this case, it should be making 2 additional resources, our bucket policy, and then the bucket public access block. And we can see that right here, plan 2 to add. Here's the changes it's going to make. And then we can do Terraform apply. Then yes. And there we go. So while the bucket is public, we said that only the objects can be accessed. We don't have any objects in our bucket. So if we try to go in here, again, we'll get access denied. There's nothing in the bucket. But before we put objects in there, Christoph, how are we looking?
We're looking good. We've got one question. I think we'll hold off until we look at actually modifying resources because it's more relevant to that. But I'll mention it now so that it's in the back of your head as you're talking about this, which is what would happen if we go into the console. So we're deploying these resources with Terraform using IAC, and then somebody else, let's say, goes into the console 3 days from now and they make modifications to those settings. How would that affect your Terraform state and things like that? I don't know if you want to address that now or hold off until we start modifying these resources.
Yeah, so I actually was planning to cover that in a little bit here. So we'll definitely hit that. Okay, so the next thing is let's go ahead and create our website. Now I've got a file here already. It's basic. I'm not a web developer. So we're going to go ahead and put this in our bucket. And then when we set up the website, it'll say, your name, S3 website. So make sure you have an HTML file with that. You can put whatever you want in there. And so now what we're going to do is create a resource that uploads that HTML file to our bucket. All right, so again, we need our buckets. It's also going to be the ID again. S3 bucket, bucket1.id. We're going to look at key, which is the file name in the bucket, which will be index.html. So that is key for your HTML file. You want to make sure that you name it index.html. And then the source is again going to be index.html. And then the content type is going to be text-html. So this is key. Like if you don't put this in here and you try to go to your website after it's all configured, it's going to actually just download your HTML file by default. So we're going to do, content type of text/HTML, and then when we go to the website, it, opens the website as normal. And then we're going to do a source hash. So essentially what we're doing here is we are taking a hash of our index file. So if this changes in the future, like we can make a modification, that hash will change. And so therefore, the next time we run Terraform, it's going to detect that the hash has changed, the file has been modified, and upload the new one here. Just like that. And then I am going to move my index file into the same location. So you'll want to make sure that you have your index file and your Terraform in the same location for the sake of this example. And then, so that's going to upload once we apply this, that will upload the file to the bucket. And then we're going to actually configure the website configuration for the bucket. And again, we need that same bucket value. It's also going to be ID. And then we are going to set an index document, the suffix being index.html. Now, there is a way, like you could upload an error document. So if for some reason your bucket's not reachable, it could display a error message instead. Well, we'll just keep this simple though and just display our website file. All right, so that's it for that. We just need to run the Terraform again. But before we do that, any questions? How are we looking?
A quick question. Are you willing to share the link? I don't know if you have this on a public GitHub repo or not. Are we able to share the link to this source code repository at the end?
Um, yeah, so yeah, I can do it. I'll just have to create that and then I can share it. I'll
What
make a
we
note
can
of
do,
that.
if it's not already set up, to not distract from this, what we can do is after the fact, when I send the recording itself, then we can send the link. That way, you can see what it actually looks like when it's finished. Especially if you have any syntax errors or anything and you're following along, I think that'd be pretty helpful.
Sounds good. So we'll do a Terraform plan here. Make sure everything looks good. It's going to make two resources here, one being the website configuration, and then the other being, or I guess the configuration's up here, and then this was uploading the website. So that looks good. We can do a Terraform format, just best practice here. Make sure everything looks good. And then we'll apply that with Terraform apply. Type in yes. Okay, so that's done. So we've created the bucket, we've uploaded the website file, we've done all the bucket configurations. We've given everyone permissions to view the website. So if we go ahead and refresh our page here, oh no, what happened? Maybe it's a cache issue. Oh, demo gods are not doing me good today. Okay. That's fine. We can troubleshoot. This stuff
Yeah,
happens.
there we go.
Oh. Uh, so let's review the bucket policy. JSON encode, get the version, and CMS, object. Oh, you know what? I don't know if this is it, but try that again. All right, and then we have the X, three buckets. The index file key, source, content type. The bucket in there. All right. I have no idea. Oh, it looks right. Now let me just put this in a different browser and make sure it's not a cache issue.
I'm also trying to compare it to the code that we have on the lab page itself to see if there's a typo or something like that.
So, you guys, this stuff happens. No matter how much experience you have with this, there's probably some missing comma somewhere.
Yeah, I'm not seeing anything standing out here, but it's probably something very simple. Usually when you have access denied on an S3 bucket, it's going to either be your identity policy, which in this case, we're making it public, so that should not be the case, or it's going to be the bucket policy itself. I don't see any typos in your bucket policy, so I'm not sure why it would be blocking it. But typically when it comes to S3 access denied, that's a good place to start troubleshooting, right? So
Something.
that's a good idea. I'm seeing a couple of comments coming in. If you want to share the website URL, we can check in our browsers as well to see if it is some sort of caching issue. That is a good idea.
Where do I put it? Just under the Q&A?
Yep, if you go under Q&A at the very bottom, just the message box there should send out to everyone. We've got somebody else saying they followed the code and it's working for them. So I'm pretty sure you have a typo somewhere. Yeah, but I'm also getting access denied as well as the others following. Nice. Yeah, we've got a working website here. Let me go ahead and project it to everyone so we can see.
Yeah.
You go to that bucket. That's one of the workshop attendees here that put this together as they were following along, and you can see their website is pulling up successfully. So nice work, very nice.
Good job.
I can't seem to select the URL on this. This is kind of annoying. I'm trying to copy and paste it, but you can't. Let me instead of projecting, I'll go ahead and copy and paste into general chat. That should make it easier. And so as you can see, it doesn't matter where you are, right? This is global. So you could be in a completely different country and you'd be able to access that website, which is of course what you would want and expect for a public website. Also, though, on a darker side of the equation, if you accidentally make your bucket public access and it has sensitive data in it, that's a good reminder that anybody around the globe would also be able to access that information. So this is one of the rare cases where you want to allow public access to S3 buckets. Otherwise, usually you want the complete opposite of that. And that's a good illustration of why. Yes, there's a good question here. Actually, there's a series of good questions. Maybe we can start answering those as Tyler tries
Yeah.
to troubleshoot what's going on. But one of the questions is, Is S3 brute forceable, like something with a directory search or anything like at all? There is, and you can search online. You can type like GitHub S3 enumeration or S3 brute force, and you'll probably find a decent number of open source tools that can help you find all kinds of things. It could be anywhere from subdomain takeover, enumeration, or misconfiguration to whether it's a public bucket or not. So you can definitely find a lot of tools like that. We actually have that Amazon S3 or securing Amazon S3 course where we're going to have some of this S3 subdomain takeover content. And we're also going to show you how to manually do some of that, as well as use automated approach to do it, because it's one of those situations where you definitely cannot rely into using security through obscurity and think, well, you know what? Nobody's going to know this S3 bucket exists, so it doesn't matter if I protect it or not. Somebody's going to find it. And there are very, very easy ways to do that, even if you're not sharing that link with anybody online. So great question. Otherwise, we had a question that was about, let's see, what was it? Let me project it. It says, how can we validate when a bucket is publicly accessible in a Terraform template? I think what this is asking, Tyler, is can we scan our Terraform files for this misconfiguration if we don't want it to block public access or to allow public access, excuse me?
Yeah, we definitely can. So there's tools out there, TerraScan, TFSec, Trivy. They come with out-of-the-box rules, but you can make your own rules as well. And those would allow you to scan for things like, hey, is this resource publicly accessible? Is this IAM permission policy, not granular enough? There's a ton of different things we could do, but that's how you would do it. That's how you would scan that code and identify that within the code itself automatically.
Another question is, if we host the website in S3 and point it to a domain or have a reverse nginx proxy, in that case, is our S3 safe? I'll start off by saying it really depends on what you mean by safe. So if you're trying to hide, like S3 is one of those services that's going to be very different from, say, EC2, because if you're running an EC2 instance, which is basically just their virtual hosts that you can use to host websites or whatever, if you're running on an EC2, that EC2 has confined resources. You're paying for X number of resources. So if somebody finds that IP address of that underlying EC2, they can DDoS attack it, right? They can run it into the ground to the point where it exhausts all resources. You can no longer serve legitimate traffic. S3 is completely different. It's a managed service. You don't control any of the underlying servers. And so in that case, you don't necessarily have to be as worried about trying to scale up or anything for a DDoS attack. Now, you can do things like using a CDN like CloudFront or Cloudflare, and you can put that in front of your S3, and you can do geolocation restrictions or a series of other types of restrictions. So you do still have some threats that you have to be aware of. And so it really depends on what you mean by securing S3, but it's going to have very different concerns or requirements than something like an EC2 instance would have if it's serving your website. What would you add to that, Tyler?
I'm sorry, I was trying to troubleshoot here.
Sorry.
I mean, there's some other things that you can put in place. So like you could put CloudFront in front of your websites, and then you can, that way the traffic has to go through CloudFront to access the website, and it's not the user directly accessing it. So that's one example.
Follow up to that, they mentioned, for example, securing from publicly exposing or getting caught by tools that you mentioned earlier. So in the case of an S3 static website, you're typically okay with publicly exposing it. So at that case, if you have, say you have some sensitive data that you're storing for a different application, and then you have your static S3 website, you'd want to host those ideally in completely different AWS accounts. That way there's very little chance that you are trying to configure something on one bucket and you accidentally configure it on the other bucket, right? You would have to use different credentials or jump into the different account, et cetera. So if you, in general, best practices, if you have sensitive data versus if you have public buckets, keep them in entirely different accounts. If for some reason you're not able to do that, I don't know why that would be the case, but if you're not able to do that, or if you don't want to go multi-account, then you'd still want to create entirely different buckets. You have one bucket where you block public access, the other one where you can allow it, and you separate those files into the corresponding bucket. So that would be one thing that I say. Now, I had something else in mind I was going to mention in response to that, which is, oh, if you're talking about trying to prevent publicly exposing buckets, another reason I recommend completely separating by account is because there's a setting you can set that prevents you from, in fact, Tyler, that might be your issue unless you've used this account for this demo before. But if you're still getting access denied, it just clicked. If you're allowing public access, but you're still getting access denied, even though you're not getting an error when you're setting that setting, if you at the account level are blocking public S3 access, then it doesn't matter what you set at the bucket level. The account is going to prohibit you from doing that. So that's a security technique that AWS added in because this was happening with enough frequency that they eventually just said, you know what, you can block it at the entire account level. That way, even if an engineer misconfigures it, you're good to go. So I would look into that setting and make sure that you enable it at the account level if you never want to have public buckets within that specific account.
So I did get it working. It's up and running.
Awesome. Hooray. Do you know what the issue was?
No, honestly, I just copy and pasted from some working code that I had before. I
Gotcha.
don't know.
Yeah. It's probably just a single line that screwed everything up. Gotta love that.
Yeah, yeah. I'll have to look and see if I can figure it out.
Some
But
other suggestions
yeah,
coming
go
in
on.
about protection, CloudFront, ACM, all that. There's a lot of different. It really depends on the use case and what you're trying to do with it. But there are definitely a lot of security controls that you can deploy depending on what you're doing. And then another really good one that we will mention here. Thank you for bringing that up. You can definitely block write access separately than read access. And so again, you almost never want to have complete public write access because then somebody could upload malware to your bucket and they could send that link to somebody else. And if it looks like a legitimate company, then they might trust that link, download it, and then they get infected with malware. So very rare that you should allow public write, even if you are allowing public read. That's a great point to add.
So I do have that example someone asked earlier about, what happens if someone modifies your resources outside of Terraform. So in this case, I've got this AWS CLI command. You could just go into the console and do this as well. Um, but it's going to change all of this, all these false to true. So if I run that, we reload the page, access denied, right? Because we're blocking all that public access now. And if I run the Terraform plan, so what Terraform's doing is it's reaching out to this resource, it's enumerating the configuration of that resource, and it's saying right here, oh, look, currently it's set to true, but based on your code and the state that we know, it should be false. So it wants to do an update in place. We can do a Terraform apply. And now it's going to change from true to false and make the bucket public again. Cool. Any other questions?
trying to go through and make sure I did not miss any questions. I don't think I did. If you asked a question we haven't addressed yet, please go ahead and resubmit it because we've got a lot going on in chat. So I want to make sure I don't miss it. We've got another question that says, if we deploy a bucket manually, is there a way to get the state and corresponding code for that bucket? I'm assuming through Terraform.
But yeah. So, we already have this. So this is the working bucket, the one with the 2, 3. Okay, and that's in my Terraform state. So I'm just going to remove it from state. So we could remove it. I'm just actually going to delete the whole Terraform state file and then the backup. So now if I were to do like a Terraform plan, it's going to be like, hey, well, I don't know about this website. Therefore, I'm going to go ahead and create this all. And if we try to do a Terraform apply, it should error out because the resource already exists. The bucket already exists. So this kind of sets up that example of like, hey, we have this resource that exists out in AWS. How can I bring it into Terraform? And there's a couple different ways, but we can do Terraform import, and then in this case, we have several different resources. So we would have to go through one by one and import them. So we would take, for the bucket, we would take the resource name, just like that. And then you'll want to look at the documentation. It's going to be the bucket name, but on here, there's this import right here. We can click on that, it takes us down, tells you how to import the resource. So I was showing you with the Terraform import commands, we just need the bucket name. So if we grab that bucket, it's going to import it. We can see it in the state. And it's back to being imported. Now that was just for the bucket, right? Keep in mind, like you would have to go through and you would want to import the bucket policy. And each of these are going to be a little bit different in some cases. So you'll have to look at the documentation to see what it needs to import it. Yeah, in this case, it's still the bucket name, but that's not always the case. The other option is you can do this import right here. And I'm just going to make a clean page here. And then you would want to create a resource. Let me set this up real fast. This would have nothing in it. And then the ID is that bucket name, which again is this. Not all that. Just that. And so what I'm saying is I've got this S3 resource and I want to import it. So let me remove the old one from state. Sorry, oh, yeah, okay. I'm just going to remove those state files again. Okay, so I've got this resource and I want to import it. Here's the attribute to do. So we can do Terraform. Well, this isn't going to work because I have all the files in the same location. So let me just make a new directory. Just call it temp. We'll move main3 into temp, change into temp. Okay. Doing a init. One to import. Let's see the configuration there. Now we have it imported. So 2 different ways of doing it. This way is a bit more, more steps involved than just the CLI command.
So we're nearing the end of our time here. Was there anything else you wanted to touch on? I want to be respectful of your time, so we can start to wrap up. But was there anything final you wanted to make sure we mentioned? I think we covered it all, right? You showed destroying. We updated some resources. Obviously, there's a lot more you can do with Terraform, right? This is just an introduction. It's a very powerful tool. So maybe we can continue this series and kind of build on top of this and deploy more types of resources, see more useful scenarios. But I appreciate everybody's engagement today. We had some fantastic questions and support when the demo gods were not in our favor. So thank you everybody for contributing, and thanks for attending. I hope this was helpful. I hope you were able to learn a thing or two about both AWS and also Terraform. If you want to pop some feedback, feel free to shoot me a DM on Discord. I'm always receptive to getting information from attendees on what we can do better next time, how we can improve it. Just as a quick reminder, yes, this is recorded. We will be sending it out. Give me about 24 hours or so to get that email sent over to you. And then hopefully we can send that link to a GitHub repo that contains all the code that we looked at today. That way you can copy and paste, or you can compare with yours and make sure that it's working in your environment. If we went a little bit too fast for you today, if you're not as experienced in AWS, I'd recommend that you, as a homework exercise, that you look up more information about Amazon S3. S3 can be a complex service in some ways, but it can also be a very approachable service, a very beginner-friendly service as well. So I'd highly recommend that you just spin up an AWS account and then go in S3 and just play around with it, see what works and see what doesn't work, and get started with that. And then come and revisit Terraform and trying to apply what you were doing in the console using infrastructure as code. Tyler, thank you so much, man. I really appreciate your time. This was awesome.
Yeah, thank you for setting this up and having me on. Appreciate it.
To wrap up here, I'm going to share my screen because we had a couple questions that came in asking for the link to the lab so that you can practice if you want to jump in on that after this presentation here. So feel free to go to cyber.com/Terraform. All you need is a free account, no credit card required whatsoever. You can go in there, you can start the lab, and then you can follow the instructions that are basically step-by-step, but without the additional context that Tyler was able to provide today. So thanks everybody for attending. Tyler, thank you again. Really appreciate it. And we'll see you in our next webinar.
Thank you.